Good afternoon, everyone. What you're going to see is can't believe how close the similarities are between what we're doing and Cerro Bayo, but we'll walk you through a very interesting project that we have with El Toki. El Toki is owned and operated by Nearstar. Nearstar is a Belgian company. According to the capital market, it's the largest on the Belgium Stock Exchange. They purchased the property from Breakwater Resources in 2010, and it's located 800 kilometers south of here. It's and about a 2-hour drive north and east of Coyhaique. It's in a remote region, and as a result, we're off-grid. And the groups that owned the mine over the years had done a very good job in terms of foresight in ramping up production. When the project was founded in 1983 is when production started. They were only processing about 400 tons a day. Currently, we're processing about 1,800 tons a day. It's lead, zinc, silver, and gold. We have the same issues as Cerro Bayo does. We have about 3 years of reserves ahead of us because we're an underground operation. But we've had 3 years of reserves ahead of us for the last 30 years. So the possibility of the potential for additional resources and reserves is pretty positive. The number of people that we have working for us are around 400, with a couple hundred as contractors for concentrate haulage and for catering services. We're processing about 630,000 tons a year. 42,000 tons of zinc in concentrate is programmed for this year, 1.8 kilotons of lead, 8,900 ounces of gold, and 117,000 ounces of silver. What we have in our hybrid system, the main source of power currently is diesel gensets. We have 2 units of 1.2 megawatt and 3 units of 1.6 megawatt. For hydropower, we have 2 Francis turbines from Spain, 1.1 megawatt each. And to end the hybrid system, we have 6 windmills supplied from France, 0.23 megawatts each. So we have the total installed capacity of 10.8 megawatt, and as I said, we're off the grid, so we're strictly self-propelled, self-generated, and we've had some days where we've consumed 6.3 megawatt. Generation, diesel is 54% of our consumption, hydro is 37%, and wind is 8%. The total average cost per megawatt hour produced is $148 a megawatt hour. Oops. Here is a very good representation of where our dry season is and where we have to rely on diesel generation versus water. And you can see our dry season is February, March, and April. And our diesel consumption is much higher during those 3 months. And then as the river flow increases, we're able to operate our hydro at its maximum capacity. Wind is variable. You can see through the blue portions on the screen. Oops, sorry. Through here. It's variable with the climatic conditions as well. And another representation with the flow in cubic meters per second of the river. And here's a representation of the total power generated at Toki for the last 10 years. You can see our demand has been increasing because the mine is getting deeper. We're having to pump more water from underground, and the increase in the throughput that we've gone from 400 tons a day back in the 80s up to 1,800 tons a day. That's just a reflection of increased production. And the last 10 years of power generation, diesel versus green. Still, diesel is about 46%, or green is about 46% of our total consumption. And as you can tell, the diesel price affects the cost to produce. Currently, in our budget for this year, we have $1 a liter, $1 US per liter of diesel delivered to site. And with the current oil price, we're actually paying about 70 cents a liter right now, which is good. The hydraulic power plant, here's our intake structure. It's for the 2.2 megawatt plant. These are gates that we can raise and lower based on how much water we want to send to the plant. We also have a limit on closing those gates because we have a requirement with the Chilean government to have a minimum flow going down Rio Toki so that we do not affect any of the aquatic life. This is a photo. It's not all that great, but here's the penstock. We're standing on top of the storage structure for the water. Here's the penstock, and here's the plant. Water flows through the two turbines and then discharges into Rio Toki, which is here. This is the power plant itself. It has a overhead crane to service the two turbines. So we have water rights for 7.5 cubic meters per second, and we can operate both hydroturbines full out for 8 months in the year, and then as the river flow drops, we normally take one of the units offline. We have high availabilities on the units. We have a very structured maintenance program with condition monitoring for vibration, oil analysis, obviously, and then we follow to the letter the operating and maintenance manuals for the units, and we have very, very high availabilities. Wear parts and components, they're changed out every 10 years, and currently, we have a third turbine that we received financing from corporate as it's a growth project for $3.5 million to install a third turbine. And that should take us from 45% green energy production to 65%. Here's a photo of the turbines. Here's the discharge from the power station. We've actually seen salmon and trout in that canal. So if you want to come fishing, you're more than welcome. It took us a long time to get the second set of water rights to allow us to put the third water turbine in, and it also took us quite a bit to get corporate approval to spend the $3.5 million. But it's underway. We expect to have the third turbine online in this September. And we've got some issues with construction because the weather is pretty harsh in this area. During the winter, we'll have temperatures as low as minus 15, and that's about what we're heading into right now. Also, the skill level of the people in the region is quite low, so we've actually had to bring some other people in from up north to help us during the construction of the machine. For our wind farm, they're produced in France. We have 6 units. They're 250 kW each, 3-phase, the 2-speed operation, 31 and 47 RPM, 2 blades per unit, and they're 55 meters high. They don't look all that impressive until you see one on the ground, and I have another photo to show you of that. The maintenance is set up on a tripod arrangement, so to drop these down, you use a series of cables, and they just lay down on the ground. It does not require any crane to access to do any servicing for the units. The length of the blades are 28 meters. The main drive unit weighs 9 tons. We have a wind range where you can operate the units. It's between 5 and 8 as we operate at the low speed, and then once the wind velocities get up to 8 to 22, we can operate at 47 RPM. There's one of the units down for an inspection. The advantage for Toki and the decisions they made to put the wind farm in were strictly economic driven. The price of oil was increasing. They didn't have the water rights to install another turbine on the Rio Toki as we do now. And so they went with 6 turbines. The time to install the turbines from purchase and installation was 8 months. Once we got the authority from the government, that only took 2 months. So it was economically driven because of the worry about the price of oil and where it was headed. Here's one of the units down with the tripod system for servicing. No crane required. The problem with this is if the wind velocity is too high and you have a unit that's ready to go back up, you can't. Either. Wait a little bit. When you've done your maintenance and the wind is too high above a limit, you can't lift them back into position and start operating them again. Conversely, if you have a unit that's gone down in operation and the wind is too high, you can't drop them down to do maintenance. So it's very varied for availability just based on wind velocity for the units themselves. So that was the high cost of the diesel that drove us to put in the turbines, and we did not have the water rights. We've actually had to change the design on the blades because they were designed for something other than what we're experiencing. Wind velocities were way too high for wind gusts of more than 25 meters a second. And when they get that high, we actually have to turn the machines off as well. But the wind gusts, that velocity pretty much never lasts more than 8 hours. But we do have a lot of wind. So it was a good decision to invest. Here's another picture of the unit. You can see the size of them. They're quite large. We also have some problems with operating the units when the temperature gets too low. We have to shut them off. I think that was a bit of a design criteria issue. I don't think they included what the temperature range was at El Toki. We can get down to minus 15. We have problems with the blades at that, plus we have problems with the hydraulic system. The temperature affects the viscosity of the oil, and we have to shut them off as well. We have a supervisory control system because the units are 3 kilometers away from the central control room, but we monitor it through a fiber optic system as well. The hydro plant, we have 4 people that operate that, working 7 on, 7 off rotation, so we have to man that 24/7. And again, because we have a very dependable maintenance crew for our power generation, because if we didn't, it would affect our productivity. We every 10 or whatever the manual says, for example, on the diesel gen sets, if we have a top overhaul based on hours, we do the top overhaul. If we have a major overhaul, we do the major overhaul. But once the units reach 60,000 hours, we change the genset out completely. With respect to the turbines, the water turbines, we do maintenance on those and monitor vibration and check the oil routinely. So we have high availability with those. And we don't have high availabilities on the windmills because of the issue with the velocities. If they go down and the wind's too high, you can't bring them down to do maintenance. And if the wind is too high and you've done maintenance and you want to put them back into service, you can't. So that's just an unvariable that we have to learn to deal with. So the estimated annual savings on diesel for the third turbine is about 6.5 million liters. We are looking at a 2-year payback, which falls within the reserve base that we have for Toki. The reduction in, or the installation of this third turbine will also have an impact on diesel generator maintenance because it will extend the life of the hours in between those top overhauls and complete overhauls, because we're actually able to produce 65% of our energy requirements through hydro or through green energy once the machine is operating. And we also have 2.8 million liter per year of diesel savings because of the of obtaining the water rights for the Rio Toki. And thank you.